we're the SWAPC squad, and our project is the low SWAPC space, weight, power, and cost unattended ground sensor. My name is Melanie Marcello.
I'm Olivia Soliday.
I'm Ian Malcolm, and we also have Nathan West, who couldn't make it today.
And I'm Megan Ignatowicz.
And our mentor is Professor David Ali. So our problem statement is that current detection systems today are large, expensive, and limited. At low cost, a low-cost and power-efficient sensor can be designed using open source information and off-the-shelf electronics. This type of sensor can be implemented in a quick, efficient manner and allow for extended use in different environments. And the sensor can also be utilized by store and homeowners for offering a low-cost option.
So for our project overview, our project is a human detection sensor that outputs the number of people detected in an area. First, a passive infrared sensor detects movement, which then will prompt a camera to activate, and using machine learning technology, it will determine whether the movement was caused by a human. The sensor is powered by a 9-volt battery, and the Arduino is connected to a Bluetooth or Wi-Fi module that transmits the data to the user. The overall code used to program the sensor is a variant of C++ that the Arduino uses.
Our component specifications include the use of the Arduino Do and Adafruit Feather MO Wi-Fi, also the HC06 Bluetooth module, passive infrared sensor, PIR sensor, Grove Vision AI camera, our 9-volt battery, 5-volt buck converter that is in parallel with the 9-volt power supply, an LCD display for debug, and our future designs, we would like to implement a geophone for a quicker response time on movement vibrations. Our electrical block diagram for our system includes the 9-volt main power supply. This is being bucked down to 5 volts specifically for the PIR sensor to stay on during sleep mode of the full system for power conservation. We will be utilizing an I2C bus with your Arduino that has 3 different serial addresses and 2 I/O ports, both digital and 1 analog for the future use of the geophone.
For this project, we have 3 different prototypes, with the MSP430 on the left being dropped in development due to library incompatibilities. The other 2 prototypes we had were an Arduino Do setup in the middle, and then on the setup on the right is the Adafruit Feather MO Wi-Fi board. Both of these setups share the same sensors and data collected, with the only difference between the 2 being the transmission of data, with the Do board being primarily Bluetooth transmission based and the Adafruit being based in Wi-Fi collection to a central server.
So for our testing results, on top of the sensors that we're currently using, additional sensors were tested to add to the redundancy of the sensors. Those sensors were the acoustic, the time of flight, and an ultrasonic sensor. However, none of these added to the data, so they were ultimately not used in order to conserve power and space. Additionally, an MSP430 was to be used, but it did not synchronize with the camera, and time did not allow for us to synchronize it. And the current sensors used provided the best data and allowed for a sleep mode to be to conserve energy. And that concludes our showcase. We appreciate you taking the time to watch our video.